Hi, hello everyone. So thank you for everything for introducing me. So today I'll be guiding you all into a technology introduction to WebXR. I hope that at the end of the presentation, you'll have a better understanding of what WebXR is and why you should interest yourself to it. Here's a bit about me. I'm Kevin Picchi. Here's my Twitter handle. I'm a developer advocate for Samsung. In Samsung, I work inside the Samsung Internet team. You might know Samsung Internet as the pre-installed browser on Samsung devices. You should also know that it's also available on other Android devices. Samsung Internet is an evergreen browser, so that means that we're constantly working on integrating the latest web technologies available and keeping updated with the standards. For example, the latest one that we've added are WebXR and progressive web apps. I don't only work with developer communities. I also go to conferences, give talks, but we also work in web standards. We try to be involved as much as we can to improve the web and to bring new features. With that, we try to have a thought leadership and look around and try to find new idea and how we can apply it to the market. And putting all of this together, we also do a lot of project research. As we're near to developers, we kind of know what people want, and we try to create new standards and bring new things to the web ecosystem. Back to the presentation, I'm going to introduce you to WebXR. But firstly, we need to understand kind of the word WebXR. What does it really mean? So as the name indicates, we can see two particles, web and XR. So hopefully everyone knows what the web is. We can define it as the World Wide Web, kind of like a technology of information. And we can access those information with the help of URLs. And all of that is available through internet. About XR, it is a bit different in a way that it's new and there is some lot of misconception about it. But to explain the name a bit more simply, we can see the X of XR as kind of like a variable, like in algebra, where you can put any letters that you want, and the R just as reality. Defining reality is a bit harder, in a way that it becomes a philosophical question. And the more I think about it, the less I know about it, in a way that what is real? Like, what is it tangible? Or there is many questions that comes up to my mind when we talk about reality, but sadly, I won't be able to answer any of those today. But I can talk to you all about virtual reality, which is one of the terms that XR mean. For virtuality, I think most of the people know what I talk about when I talk about virtuality, but it's basically a complete occlusion of the view. Let's say you're wearing a headset and you wouldn't even be able to see what's around you. And we would be using virtual imagery, and you would be kind of transplanted in another world, in another reality, if I can say. We also have AR, sorry, which is the other term that we think of when we talk about XR. As the name states, it is an augmentation of the reality. And as you can see here, we can add and display and overlay information on top of the real world. So as you can see here, we can have the size of the branch. We can also have like an indication of where to cut the branch or other information guides. These two terms I just mentioned are kind of the main one when we talk about XR nowadays. But we could also talk about mixed reality, which is a way to combine these two approaches together. Why are we talking about the web today? Firstly, we need to think about the user. Not every user will have the same devices, and we need to make our content available for the wide selection of devices, and we also need an accessible technology. And the web is pretty spread around the world, I can say. And in terms of devices, we can support every devices. When we think also about the content, we want our content to reach, to have a maximum reach, and to be able to go everywhere in the world and be experienced by as many people as we can. And we also need a frictionless acquisition process. To put it in simpler words, just to make the experience accessible through like things like simple as an URL or a QR code, where you can imagine a user just scanning a QR code and appearing in a virtual world. So this is why I think the web is a good platform to work on VR and XR in general. With web, we need also to think about how we access the web. And usually when you access the web, you're using a browser. And when we talk about browser, we also need to think about support. As there is many browser, and it's been like this since like a lot of time, even before I was born. We need to make sure the browser is supported. And for now, if we talk about WebXR is supported on most of the common browsers. Some of them, for some of them, it is running behind the flag, where you need to be in development mode and enable some settings. But WebXR is coming to your screens, and it is being pushed to production on a lot of browsers. But we don't only have to support browsers, we also need to support the hardware. So in that way, we can define a few different types of displays. Here you can see the opaque display, transparent display, and video pass-through. When we talk about opaque, kind of think about something that we can see through in a way that we transported in another world, and we lose the vision about our reality. Transparent is just displaying stuff on top of stuff, you know, like that would be reference to AR. And video pass-through would be seeing things through a screen or video, where you'd be using your phone to see around a world or experience some of these stuff. I also have some example of devices here. Of those devices, for example, here the Samsung Odyssey, which is an opaque device type of display, where, as you can see here, like you're kind of losing sense of reality when you put this on your head, and you lose complete control with the real world. Here we got the Microsoft HoloLens 2, which is a transparent type of display. As you can see here, the visor is completely transparent, and it's acting kind of like a screen where we can display more information on top. And I was talking about video pass-through, and here's, for example, the Samsung Galaxy S10 5G. where we can experience video pass-through in a way that we use it just as a magic window to see another word. There's not only the type of display that is important. There's also the type of tracking. As you might know, when you put one of these headsets on your head, we kind of like when we generate and render the word around you, we need to think of the orientation of your head or the movement of your heads and make the experience react properly. So this is why there's two different types of tracking. Here's, for example, here at the top, the magic window I just mentioned with here Core Kit, for example, where you would be using your phone, seeing a magic window inside your screen and be able to experience three-dimensional words through your phone. AirCore would be the use of your camera and display information on top of what your camera sees. And we also have two other main types. Here, the 3 degrees of freedom type of tracking, where we're only going to be able to have the orientation of the device. So we can have the orientation of the remote and the head of the user and where the user is looking, but it stops here. And a bit as an improvement to this one, we have the 6 degrees of freedom, which are headsets that are able to track the orientation, but also the position in a way that we can have the transition, the 3D transition in the space. So we'll be able to say where the remote controller is and display it to the user and respond accordingly. When we talk about these two, we kind of think that 3 degrees of freedom is kind of dying, and I wouldn't say it's totally dying because there's a lot of way you can still experience it. Even though if you look at the market right now, there is many of those 3 degrees of freedom devices that have been discontinued. But it is important to say that it is still in use, and even though we're kind of aiming to a 6 degrees of freedom type of tracking, type of main tracking, 3 degrees of freedom still exists. And I've got a few examples. So for example, here, the Google Cardboard. As you may know, it is just a box where you slide your phone in and you're able to experience 3 degrees of freedom type of tracking. So no transitional movements, you only get the orientation. Here again, with the Samsung Gear VR, again, 3 degrees of freedom, but it's compatible with, for example, this controller, where we also get the 3 degrees of freedom. Here, for example, we got the Oculus Rift S, and it looks big, heavy, bulky, but we got 6 degrees of freedom, and we can have the position of both hands and have the position of the head of the users, so we can move in a room and being kind of updated in our world. Obviously, we also have the orientation. Even if you don't have a headset, you're still able to dive into the experience using, for example, a phone. Obviously, it won't be an experience that is that immersive, but you'll be able to see, you'll be able to experience it anyway using a phone. This is what brings me to WebXR. This specification describes the support for accessing virtual reality and augmented reality devices, including sensors, head-mounted displays on the web. So if we take that and we think about all of the devices that I talked about, there is many of them, and supporting every single one of them is hard. And this is what brings us back to WebXR in a way that WebXR is going to help us to kind of homogenize the whole devices and to have one code base around all of the devices that we have and to simplify the development and the reach. Another thing that WebXR brings us is the fact that WebXR is part of the web platform. As you can see here, there is different types of API, and I mean, there is many types of APIs. For example, here, WebGL, Web Audio, Progressive Web Apps, the Gamepad API, Web Bluetooth, and there is actually many more. And what is good about it is that once you're in that ecosystem, you can kind of play with all the APIs. And this is things that are supported on most common browsers, and it is always expanded. So you're kind of gaining access to a toolbox that would allow you to mix and match and play with all of them and create your own experience in a unique way. If we look a bit more about how we use the WebXR API, we can take, for example, here a browser, which is Google Chrome. And if we open the developer tools, we're able to use the console and type in navigator.xr and see if it is supported. And here, if we look at it, we got the return information with the interface information about the API. And there, so navigator.xr is kind of like the entry point to the API. With this, we're able to query XR features. We can also initiate communication with XR hardware. And we also have a list of the XR devices that are actually connected at this point on the computer, for example, or any other device. As you can see here, we've got a support session mode, which is going to return us the different sessions that are supported on the browser that we're actually using. And this is important so that we can provide the accurate experience to the different users. So as I said, if you want to run WebXR on the browser, there's a few steps that you need to follow. And one of the first one is check the session, as I just mentioned. Look at which session are supported. Here, for example, you get a few ones like the inline session mode, the immersive VR one, and the immersive AR one. As the name states, immersive VR is mainly done for VR, and immersive AR is for AR. But the inline one is kind of like a way to access an experience through and inside the frame of a browser. So it wouldn't be like a complete experience in a way that we're immersed in it, and it would be just a view inside a browser. And if we look at this and the current state of the WebXR API, the VR has pretty good support. Although the AR one is not, it is still work in progress, as I would say, but there is many ways you can still engage with it and work with it. For example, we've got, there's different modules that would allow you to work in, for example, 3AR, for example, I mean, you could be using your own JavaScript API or even 8-1 technologies. So AR is coming and you shouldn't be afraid of it. The second step is to advertise to the user, advertise that the experience is available, advertise that the user can join your virtual world. And this is done by displaying this little square that you can see on the bottom of the screen. This is mainly done so that we kind of want the consent of the user before like teleporting him into an experience or in a 3D world. You wouldn't like to be teleported into one 3D space or another without your consent. So this is why it is done. We also need to wait for the user activation. So once the user activates, we can request an excite session. And once we have the session, we can run our frame loop, which is going to be basically calculating the different thing that we want to render on the screen or in the device of the user. Now, this is a bit archaical, I'd say, in practice. And in practice, I think you'll work on projects and you wouldn't be touching those native APIs directly. So we're probably going to be using different frameworks. So I've got a few of them here, Three.js, A-Frame, Babylon.js. It is worth to note that there is many more in the market, and this is just 3 of them I randomly picked, just because I like them pretty much. Here's just a few points that I want to mention. For example, Three.js doesn't really have an integrated physics library inside, but it is closer to Metal in a way that it's gonna be harder. It's gonna be sorry. It's gonna be easier for us to interface with more middle hardware, or even if we want to do shader rendering, this kind of stuff will be easier with Three.js. For example, here we also have iframe. Iframe is a bit more high level. We're using we can even use it with HTML, which makes it easy to prototype with, and we can end up with a very good WebXR experiences with it. And here the last one is Babylon.js. It has integrated physics, and for myself, I find it easier to use, and it has good WebXR support. A bit more about WebXR, about Babylon.js. It is a 3D engine that's going to help us to generate 3D content and 3D objects in our world. It is available in JavaScript, even though the source code of it is in TypeScript. So JavaScript is just one of the languages you can use to interface with it. And it's also worth to know that it is open source. When we talk about WebXR development, we also need an environment, and the environment is kind of like all the web stack development tools that you would use, in a way that you would be using a code editor, you'd be using JavaScript, you need a browser to debug, and there's just one different thing that you need to have. It is the WebXR API emulator. So for now, I'll show you in the demo a bit later, but this emulator is gonna emulate different types of devices. And for now, this is part of another extension that you can download. But this is gonna be, I'm sure, integrated into browsers soon. So here is the example of an experience running inside the browser. We can see here the browser with the experience, a 3D room, a 3D space. And you can see the button I was talking to you about down there, which is used to get the consent of the user. Here we got the WebXR API emulator, which is going to help us to emulate devices and test our things. And obviously here, code editor. As I said earlier, with the fact that WebXR is part of the web platform, we're able to mix and match with different types of APIs. And in my demo, I wanted to show you the way that we could use to have multi-devices inside the same experience. And for this, I used a different version of WebRTC, which is WebSockets. We could have been using. I could have used WebRTC, for example, but I've chosen WebSockets. So yeah, here that's what we're going to be using for the network communication. We will likely need the position of each user's, the orientation, and we're going to be using WebSockets, which are going to be used for the communication. Here's also an example of what the communication looks like. It's nothing too fancy. It's we can take here a user, Kevin. We also need a server, and we kind of have a bucket with all the users. By all the means users, I also mean myself. And I'm going to be sending my location, my information to the server. So here, for example, the position and the orientation. And everyone's going to receive the details of my position and orientation so that we can update accordingly to screen to everyone and the 3D space in general. So I'm going to show you my demo, which is on my computer. Give me just a second to share my screen. So all of this is done through the web. So I'm going to be showing you the scene of all of that. There we go. I guess you can see my screen. There we go. So I'm gonna show you how we can access the experience. On the screen here, you'll be able to see that on the top, I've got an experience running. To access it, I just have to go into this URL in the browser, and it is running like a web page. It is as simple as that. There's nothing too fancy about it. You just need a compatible browser, and that's basically all you need. So once I'm in the page, I've loaded the extension that allows us to emulate the WebXR API. And if I click on the button, as I said earlier here, to give the consent to join the experience, I'm going to be teleported into the right place in the 3D world. And I can kind of rotate myself around and look around. And I can refresh this one so that it's going to connect to the server, and we will be able to see ourselves. There we go. Perfect. So as you can see here on the top, we've got one player, one user, and on the bottom, another one. On the top one, I'm able to look around, and we can see the other view of the other user reacting properly down there. So the thing that you see here on the side is the development tool that we use. You can do many stuff like around orientation, look around, top to bottom. You could also emulate different types of devices. So for now, I'm emulating Samsung Gear VR, but I could be using, for example, a Quest. I'd like to mention that, for example, the Samsung Gear VR here is a 3 degrees of freedom type of device, which means that we're only able to change the orientation of it. But if I switch to, for example, the Oculus Quest, the Oculus Quest is a 6 degrees of freedom device, which means that I'm able to move the user into the 3D space. So as you can see here, my 3D models are pretty basic, and I'm sure you're all better to create one than me. Those are just taken from Google Poly, and it's just for a simple use case and for the example purposes. So yeah, as I said, if the two users move, we can see the screen updating properly, and it is awesome, I'd say. Back to the presentation. I think I'm done with the WebXR stuff, and if you'll have any questions,